Hello everyone, welcome back. So this is the last question we have in the contest, and I have already uploaded the last three videos we have uploaded. Please go and watch so you can understand what the contest have asked in these questions. And apart from that, we will do deep dive later in the evening. I'll keep posting the videos, so keep watching here. Okay. So the question is saying that longest palindrome we have to find in graph, right? Don't we uh, hurry that I'm not going to understand. This is a hard question from the graph. No, you don't need to do that. Very easy question, right? So you have to focus not to here on the hard in the red color, right? You have to focus the concept. The graph is not big headache for us, right? You just understand the concept. Question is saying that longest palindrome we know, right? You know the palindrome. What is the palindrome, right? And let's read the question first, and then we'll go through from here. The question is saying that you are given an integer n and an undirected graph with n nodes, that is level from 0 to n minus 1, and a 2D array edges. Means what we have given, n we have given, means number of node we have given, and what we have given, edges we have given, means between that edges we have given. If you see here, right, we have given what, 0, 1 and 2. How many nodes is this? 3 nodes is there. We have given what, 3 nodes we have given, right? Means these nodes we have given and edges we have given, and also saying that this is an undirected graph, means there is no directions we have given, right? But we have given number of nodes, means we can say 0 to n minus 1. So if n is 3, 0, 1 and 2 will be the possible nodes. Can we say that? It is easy. I told you first, this is easy. Don't be surprised that this is not easy. Now understand, you are also given a string level of length n, correct? Means the string that is called level, as you can see here, right? And there will be some element, because the string contains the characters of, you can say, each characters we have in the level, right? And these characters that we have here in the level, we can say each character is a letter attached to a node, right? As you can see, the very first character that we have is A, then we have B, and then C, or are attached to the node. So it is saying you are also given a level of length n size, where index at I, let's suppose, we can say level at I is the character associated with the node I, and we say that, and we can see here, right? Now it is saying that you may start any node, right? You may start at any node and move to any adjacent node, because there is undirected graph. So you can start from any node, right, and move to any adjacent node. That is fine. Now it is saying, means you can start from 0, 1 to any node, and you can go through adjacent. One adjacent is 0, 0 adjacent is 1, and sorry, 1 instead adjacent is 2 also, right? Like that. But for 0 and 1 is it is not adjacent, right? For 0 this is 1 adjacent, and for 2 this is 1 adjacent. But adjacent means all the nodes, we can say, right? So we have to visit each node at most one, means all the node we have to visit, all these 3 nodes at most once. Now what we have to do? So as the question is saying that, what we have to do, we can start at any node and we have to move to the adjacent node via these edges, right? And we have to visit each node only once, maximum one time we have to visit this node. And you must find the longest path, such that when you read the level, that we have given here, right, you can uh, uh, visit, you can say, when you read the level of what you call visiting node, either 0, 1, 2, right? This visited node, if you are moving from here in the order, can we say that, right? Means you must have to find the longest path, such that when you read the level, right, of the visited node in the order, can we say that the resulting string is a palindrome become. Let's suppose A, B, A. We are visiting this one, right? So all node we are visiting. So these visited nodes is a such a way in order that it will become an palindrome, and that is we have to return the resulting string is a palindrome. So your task is to return the length of the longest palindrome, such palindromic path we can say we have to return. And that is why if you observe here, right, it is saying the longest palindromic path is from 0 to 0 to node 2 via 1. Means you have to come 0 to 2, but you have to also go 0 to 1 and then 1 to 2. And that is why it is representing. So it will form ABA. I hope you understand, right? And that is why the answer is coming 3. Now, if you're a beginner, right, don't hesitate that I will not tell you what is palindrome, right? So let's understand what is palindrome, right? What is palindrome? So palindrome is a string that reads the same forward and backward directions. Let's suppose this is a string a, not sorry, not a we can take, right? We can say that if this is a string, we represent the string like this, right? We can say that, right? If this is your string, right, so if you'll read from this side ABA, you can read from here also, from backward, right, BA. So both side is equal. Left, when we are going from forward and backward, both side is, we are reading the same thing, right? Let's suppose we call A. If this is a string, right, we can say that this is also ABA. If you are going forward direction, we are reading, and backward direction, both are same. Let's suppose we'll say this time ABC, right? Can we read from both side? Think ABC. We are reading ABC. When we are returning backward direction, CBA. Not equal, right? This is not equal. So this is not palindrome. Let's suppose if there is only one character is there. Is this palindrome? We'll go from this side and we'll go from this side. We'll read from forward is A, backward is also A. Palindrome. Okay? Means a palindrome is a string that reads the same forward and backward directions. Understand? So let's walk through this example. Okay. So very first what we have given is, we have given n equal to 3, right? Ages we have given 0, 1, 0, 2, and level we have given ABA. Can we say that? Sorry. This means there are 3 nodes we have given, right? So if we'll write 0 is belongs to A, can we say that? Because level we have A at index 0. Then let's suppose we have another node 1, that is what we connected with B here, right? We'll say B. Let's suppose another node is C. We'll see not C, this is A. Okay, A, B, A. Okay. So what are the edges are there? So the edges are we have is uh, 0 to 1 and 1 to 2. So this is the edges we have given, right? So you will want to visualize this, so you can say this is your 0, this is your 1, and this is your 2. Just you need to do what? 0, 1, and 2, and you have to pass A, B, and C. These are characters. You will mark like this a character. Can we say that? And that is why you are seeing this, right? So our goal is to find the longest path. You have to find the longest path, okay, such that the letter on the path is palindrome. You know what is the palindrome, correct? So the question is how. Let's suppose you will say, okay, that's fine, but I don't know how to find all the paths, right? So let's try to find all the possible path. Like means we'll visit the each node, right? We'll go to visit this node, then this node, then this node at once. Okay. Let's suppose the very first I'll say path, right? And we'll say path at 0. Can we say that? Let's suppose path at 0. What we have at A? What we have is A. Let's suppose we'll say this is our string, right? So string, because this is a character, and we'll say only one string is coming as a Is this palindrome? Yes, this is palindrome. So what is the length? Length is 1. Now let's go with the path at 1. Can we say that? We'll say path at 1. What is the path at 1? Let's suppose next is coming B. We'll say B, right? Is this a palindrome? Because this is the single length. We'll say yes, length is 1, and this is also palindrome. Then we'll go for the path at 2, right? Can we say that? So is this a palindrome? Is only one character? This is not C, this is A, right? So we'll say A, right? And this is also length 1. Can we say that? So this is also palindrome, right? means all are palindrome. Now go with the path, another one. Let's call path. I will go from this time 0 and 1. Can we say that? What is the element we have here? Is we have A and B. We'll take two elements from here and here. Correct? This is valid. This is palindrome. Similarly, we'll check another path. Is 1 and 2. Can we say that? Yes, we can find what B and A. Correct? Is this palindrome? Is this palindrome? Sorry, this is not palindrome. This is not palindrome. AB is not palindrome, and this is not palindrome. Oh, sorry. Right? These are not palindrome. So this 0 and 1 is not palindrome, and 1, 2 path is also not palindrome. These two are not palindrome. Okay, so let's mark in the red color so you will understand. So this is not palindrome and this is not palindrome. So both these and these are not palindrome. Can we say that? We can say that, correct? Again, we'll clear this one. So we will understand clearly. Okay. So I was saying this is our A. Correct? Now let's suppose we'll take a path that having all these indexes 0, 1 and 2. Can we say that? So this time what we have path is A, B and C have a string. Is this palindrome? Yeah, this is palindrome. And what is the length is there? The 3. So this is the longest palindrome possible path we have here. And this is the longest path and which is valid palindrome, we can say. Right? Can we say that? And so if you observe that, we are seeing the output here is 3. Right? And this is valid palindrome. Understand? So we can say that to be a palindrome, let's suppose is two characters there, right? The first character, let's suppose we have A and B, right? So if we'll say for to be a palindrome for any string, right? The first character and the last character should be same. Very first, this is the palindrome concept, right? Then we can say if any more character is there, let's suppose there is one more character is there, BB. So this is our last character and this is our last character. So this first character and this is the last character, both are same, means we have to go with the next character. So this character is the second and second last, second and second last letters must be same, and so on. We have to go if there is more length is there, means third and third last, 4 and 4 last, till we'll go to the here if it is odd number length. Can we say that? If you have seen my palindrome videos, right, I have already explained this one. So if this odd length is there, what are the possibilities there? If this is an even one, then what is the possibility, right? Let's suppose this is odd one, so the last character will be this one. So we'll say if this is last character, means only one character, only one character is there, so this is also palindrome, as we have seen all these three, right? These are palindrome. So we'll say yeah, palindrome. But there is can be another case when, let's suppose we have A and there is B. Can we say that? So is this how many characters are there? 4 characters there, right? Length is 4. So this is even number concept. So this is last and this is first. These are same. This is the second and this is the second last. Both are same. But we don't have the further. You can say. Okay. What is the possibility? So for this it is very easy. We'll go tracking the. We'll keep reducing the window, right? And we'll check the both character, start character and last character. Can we say that? And if are same, then fine, same. But when the concept arises for the odd and the even concept, can we say that? If the concept we have is for odd and even for single palindrome, right? The concept for the single palindrome, if you observe that we have solved the palindrome problem in the DP concept. Do you remember DP concept? Because there is a concept we have what we are using B odd length finding and even length finding. Multiple approaches I have provided you, but the very tricky problem that we have solved using the dynamic programming, right? Another we have also solved, right? You can see my the Fang preparation video, right? And you can go and you can see the Fang preparation series, and you will see the last week I have provided the video on the palindrome where 3 approaches we have already told, right? So why I'm talking about, because if you have already observed the odd and even concept, right? So this will become easy for you. So that is why I'm saying this is not the hard question. If you are my student, you have already gone through the my videos, and this will become easy for you, right? So what makes this question hard, right? So you can't just do brute force approach. If you'll try the brute force approach, this will become hard for you, right? Because you have to go for all the paths. As you can see here, right, I was going through all the path, right? And there will be too many paths, too many paths will be there, right? And so it will become very you can say tough for you, right? This will become hard for you, right? That's why we will use either the concept is there, you can use DP, right? Or you can say in this that video we are going to see, we'll use DFS, right? We can use the bit masking concept will be there, and DP will be there, correct? And bit masking. Okay, so all these concepts we will include in this video. So if you have seen the bit masking, I've already uploaded. If you did the what it is called memorization, this will be also easy for you. If we are going for the DFS, it's also easy for you. All videos we have already uploaded, right? If you have still any doubt, let me know, I'll put in the comment section. Okay, then why we are using the DFS? Because we have to explore all the paths. Why will we use the bit masking? Because bit masking we will use to remember which nodes are used. And memorization, why will we use? To avoid the repeated work. We will not do again the same calculation we'll do for the multiple times. We're not going to find all the paths again, right? So now let's understand the code. So let's suppose very first thing, we have n equal to, we have given is 3, and the ages that we are talking about we have given is 0 1, and another was we have given is 1 2. Can we say that like this? We have given ages, correct? And another thing we have given is level, right? Let's say call level, we have given level will take what? A B A. The example first we have given that we will take. Okay, so if we'll talk about this, so what are the nodes are there? So we'll say that node 0 having is A, as we have discussed. 1 we have is B, right? Then node 2 we have is A, correct? So the ages we have seen is like this, what we called 0 1 and 2. Can we say that this is the what we call ages we have given? Can we say that, right? So very first what we are doing, we are initializing the required things, right? Here, so that like we want to save n equal to, we have what we have, n we have given n equal to 3 we have given, right? So we have n equal to 3, so we'll save n equal to 3. What we have given in the level, we have given a b, a we have given, right? So we are also saving this, correct? Now after that we will build the urgency list, and so that urgency list, what we are trying to do actually, we'll create a urgency list like this. Okay, like this means 3 empty list for 3 nodes. This is for node 0, this is for node 1, this is node 2. Because 3 nodes is there, so we'll create 3 nodes of the urgency list. So this 0 will contain the list of all the its neighbor node, right? Like that we will understand. So very first what you need to do, we'll create the urgency list. So you have already created the urgency here, right? What we need to do, just you have to initialize it. So for that you will go with the for loop 0 to n, right? And you will add all the urgency list. So you have initialized this urgency list here. This is nothing but your urgency list. Can we say that? So this urgency list we will add. Now we'll do processing with the another for loop that we have here. We'll process each edge. So after the processing, what will happen? This value, let's suppose we know that 0 is connected with 1, right? So here what we will put, give me 1 second. So 0 is connected with 1. So we'll say 0 node is connected with 1. So this is our urgency list. Now we'll talk about 1. 1 is connected with 0 also and 1 also, right? So here we'll put what? 0 and 2, right? And this 2 is connected with 1 only, so we'll put 1. So after processing this urgency list will look like this one. I hope you understand, right? After that we will use a memorization table, right? And this is called, we are going to initialize the memorization table, right? So we'll write dp equal to new int and we'll go we'll add like this, right? So that we will initialize, we want to create a 3D array. Let's suppose what I'm trying to say, if we have dp, right? So we'll say dp, let's suppose I want to put 8, 3 and 3. Why? Since we can say 1 is less than not we have to mask, right? So we can say 3 is equal to what we call 8, right? We'll say we'll take a left shift, right? 1 left shift 3 is nothing but 8. You know the masking, right? So we'll initialize with -1. So why we create this bit masking, right? So we want to create this bit masking. Let's suppose this is our mask. This is nothing but our mask, right? So it means this dp having mask, right? Then we have u and then you have v. Can we say that? So this is your u and this is your v. Means this is the 3D memorization table we use in the DFS to store the answer, right? So you can say why, right? Why we are going to store? Means let's suppose we want to store the what we call answer. So we can say what is the maximum number of matching character pair we can extend, or we can say when we start a pair at node u, right? And it ends at v, right? Means we already have used the node in mask. Are you understanding? Means we want to use this dp memorization table, right, in the dfs, right? We'll use this dp in the dfs. Why? Because we want to store the answer for what the maximum value of matching character pairs we extend. So when we start a path, let's suppose call node u, and it will ends at what we call v, then we already have used this node, and that is in the mask. Are you understanding? Means why this we are going to do. Let's suppose, let me clean this one, okay? Not like this. What we call, let me remove this. Let's suppose you are going to ask me why this 3D dimension we are going to use in the dp, right? So very first we have is mask, right? So this mask will say what is the meaning of this mask? Means which node have been used so far, right? So we'll have a, let's suppose call bit mask, right? And we'll say this one means we have used this node, right, so far, right? Then we have u, means we are going to start the node of the current path from here, and ends, we will ends at this node. Now you will say, sir, why we use a bit mask here, right? So see, there are how many nodes we have here? N nodes we have given, right? So for each DFS call, we must track which node are already used, right? Because if we have already used this node, I don't want to come here again. We don't want to revisit, you know, the graph rules, right? We want to stick the revisit, right? So that we will not go into the loop in the infinite one, right? So for each DFS call, we must track which node are already used, right? So that instead of using let's suppose boolean used, like that we used to do, right? Let's suppose say this is visited or this is used, right? That we used to create, let's suppose create a boolean visited, or you can say used one, and we'll say we'll mark true or false, right? That we are we are not going to do. We are not going to do. So instead of writing this boolean concept, like we are going to do visit, right? We will use used, and then we will mark it here, right? So we will use, in place of that, we can use an integer bit mask, right? We'll use the integer bit mask. Let's suppose we have node 0, right? What we have? Node 0 we have, and node 0 is used. What we will say? We'll just say mask and 1 shift 0, okay? Then let's suppose we'll node 1 is used. So what we will say? Mask and what we call 1 left shift will do, right? Like this. Understand? Less than that we are doing, that we will use here, okay? And we'll till that we'll go, so on will do. means with n nodes will apply the same thing. So the total number of possible combination used node become what? You know how many will become? 2 to the power n. Can we say that? So let's understand here again. So let's suppose here, okay. Let's suppose what I'm trying to say here. So if we have n equal to 3, that we are seeing, right? N equal to 3, and total mass will become what? Total mass is what? We'll say total mass value is 2 to the power 3 and 2 to the power n we are saying right here. So 2 to the power 3 is total 8, and that is why I use 8 there. So if we'll say mask we have to do, right, it means 0 1 2, it will go till 7. We have to mask like this, right? Means if we have n nodes, we have, means then total mask value is 2 to the power 8, means we have the mask 0 to 8 and 0 to 7 we can say, okay. So each bit in mask says is that the node is used in this path. Example, let's suppose we'll say mask equal to 5, that is what? 101. So here only node 0 and 2 use. Can we say that? Node, remember, 4 3 2 1, right? 4 3 2 1, yes. So when we write what we call node 0, so we'll mark all the 0. When you use node 2, right, what will happen? We'll use this one, right? Here one. This is for when we have 1, right? When we have 2, we'll use this 2, correct? We can say that. So here 0 and 2 nodes are used. Are you understanding? Now you will say, then you are using what? After mask you are using u and v. Why u and v? Because we are trying to build a palindrome, so we need to know that somewhere we have to start the node of the current path, that is called u, and somewhere we will end the node of the current path, that is u. For example, if we explore the path from 0, let's call at 0, and we want to go till 2, right? U is 0 and v is 2. So we might try to expand from both ends, right? We can say that we can expand from both ends. So you will expand u to its neighbor node, let's suppose u2, right? And we want to explore the node v to v2. Just for example, if there is a more nodes are there. So like that, we will explore the path in from both sides. So what we need to do, let's suppose if we'll expand this sorry, if we want to expand this u to node u2, right? And this node we want to expand into v2, means both side. This side also we want to expand, and this side we also want to expand. For this example, I'm saying we want to expand. In that case, what will happen? Let me write here. Okay, so we'll say level, we'll write level, and we'll say level at what? At u2, right? It become what? Equal to level at v2 is both is equal to same, but only will do if this level is equal. We'll expand, we'll do everything this one, only both are equal. Neither u2 and v2 should be revisited. It should has been visited only. Okay, will not go for revisited, we'll go for only for visited. So why do we use to store this dp mask u and v? We want to store it, so if we ever call dfs mask u and v, right, so we don't recompute it again. So it will save us the exponential recomputation in dfs. I hope you understands, right? But still, let me summarize this so you can understand clearly. Let me clean this one. Let's think that let's suppose why I'm using let's suppose we'll use dp 1 shift n and n. We'll use this thing, that is why I'm talking about. So this time n was what? 3. So if n is 3, then mask become what? From 0 0 0 to we are going to 1 1 1, means this 0 to 7. Can we say that? You remember? Five. What we call? Okay, forget. 3 4 5 2 1. 3 4 no 4 3 4 3 5 1 2 1 4 3 5 1. Formula is 4 3 5 1. Okay. So just remember the formula that we are using. Okay. So this is the from it will come out 0 to 1 up. It will change this bit to there, right? So it means the mask is what, 2 to the power 3, right? It means it is total is 8. That is why we use dp, we use dp at 8, right? Then we use u and v like this. So you can use anything from here. Let's suppose this is your u and this is your v, where from the current path start and ends. So this u and v can be any of the three nodes, right? Any of the three nodes. Either you was using, let's call 3 3, right? So when we write this one, means we have to say when we are doing this one, right? Let's suppose for this one, means we want when n equal to 3. So when n equal to 3 means this is your dp that we will initialize like this, dp 833, we have to say, correct? Like for example, you understand, you are playing a game, right, where you can choose which node to walk through, but only once, right? And you want to try to expand symmetrically, right? Let's suppose I was talking about second, means I was talking about what, symmetrically means this side and this side both are same, right? Means a is there and b is here, sorry, a is here and we have b is here. So if we'll take this one, it means this is a palindrome, but this is asymmetric, right? Means we want to means you are playing a game where we want to visit all the nodes but only once time, right? So so you want to try to expand the symmetry from both end, this end and this end, to form a palindrome. So at each step, you have to remember which node you use to mask, right? Some node will be there, then you have to mask it, right? That is called masking. Where you path starts and ends. I hope you understand. So if you have already tried some combinations before, so you don't need, you don't do it again, right? You just return to cache it, your result. That is why we use DP array, right? I hope you understand. Let's continue further. So at this step, what we are doing here, we will create the DP, the DP 833, and since one is one will do 2 to the power 3, right? We'll get 8, it will generate 8, right? So we'll initialize this one with the this array will initialize with the -1, we can say. Okay. Then uh, actually our purpose, what we need to do, we want to store the value at this DP, right, to store the best possible palindrome from that start from u and v, and so we'll use the node in the mask. Okay. Now we have to try odd length palindrome, means that is we have the centered one. You remember I told you there is the two type of palindrome will be there, right? Let me explain you here. Okay, second. So as I told you, there is a possibility that there is a is there, right? So this is your odd length. How many? What is the length? Length is 3, right? So this is odd length. So for this it will work. What is the even length? Let's suppose a. This is even length, right? So this is your odd length and this is your even length. That is why for odd length we will handle while this, and for this even length we will handle while this, right? We can say that. Then uh, we are doing very simple things. We are doing what we are doing. We are masking the value. So you will mask here. You will iterate through all the you can say we'll loop down for each node u, right? And what we'll call, will mask the value. Let's suppose we are going to mask value. Let's suppose this mask is equal to 1 0 for the 0 node, right? So what will happen here, it will become what, it will become 0 0 1 in binary, we can say, in binary, you know that, right? So this is the binary number, and so we'll mask this binary. So what will come, so the DFS will do like this, 1 0 and 0, right? So we'll create the masking here. When we'll call the DFS, we'll mask what, 1 0 0. Okay. So we understand what we do next, right? Means we'll check if, let's suppose we'll say if we are doing DFS 100, means let's solve if we'll check if DP at 1 0 and 0, right? If it is not equal to what, -1, it means we have already calculated this one, right? And so that time we will return what? DP at this 1 0 and 0, because we have already calculated, no need to calculate further, right? And r is, let's suppose, 0 something, right? So we'll try to explore the neighbors of 0 here, right? Which is already node 1. It means try u2, right, equal to 1, right? We'll check the neighbor of 0, then we'll bit mask again. Let's suppose this time it was 1, and we are doing masking. This is the node 0, this time node is 1, so we'll do the node 1. So we'll check, is 0 not visited? It is not visited, so it's okay, right? Then from other node, when v equal to 0, we'll check again for we have already checked for u2. Now we'll check for v2, right? So we'll check again, neighbor is v2, right? So we'll check what we call u2 is equal to v2 is equal to, we both are 1, let's suppose both are 1, correct? If both are 1, we'll skip it, will not do anything, right? We'll continue, we can't expand this, we will because these are not equal, so we'll can't expand, and we'll say same node will not work, right? And so no valid expansion will happen, and will return at 0, right? And so if you observe this, we are doing the same things, right? We are doing the same things, correct? Understand? So uh, then what we will do, we'll create another pair here. Let's suppose pair, what is the meaning of pair at 0? We understand this one, right? You understand these two things that we have understand, v2 u2. We'll do these things here, okay? Now what about this pair? What we are calling this pair at 0, will say, and best equal to will find from where max of, let's suppose this best is your coming is 1, and this is of your 1 plus 2, right? So let's suppose we'll call 1 plus call 2 into 0, right? So it will come also 1. So this pair is 0, and this one is coming what? Best is coming what? 1. Similarly, as you have find for case u, you will find for v, right? And you will check as we have understand. What I will do, the video will become bigger ones. What I will do, I'll add the dry run in the comment section, so you will understand what is happening here, okay? And so if you understand the best, right, so you have to finally return the best one here, okay? I hope you understand. Similarly, I'll do this is for the case u, right? We'll do the case b, where you will do the same thing, right? And you will find the best. What is the best will come? So in this case, the best is coming 3, right? So we'll return the 3 here, okay? Because the palindrome, how palindrome works. So we'll so to summarize this, we have to find for this loop we are going for odd, and this loop we'll do for even one. So odd and even number of palindrome we have to find, okay? Anyways, thank you for watching this video. If you still have doubt, let me know in the comment section that you have any doubt, right? I'll put the what we call uh, dry run in the comment section. If you need anything else, please let me know in the comment section that you want to understand from me. And thank you for watching this video, okay?